Hi, in this video I'm going to show you the step-by-step instruction on minimizing a DFA. So I have here a DFA example in which I have 5 states A, B, C, D, E, and as you can see there is an arrow before our first states which indicates the initial states, and in the last states, which is E, has a double circle indicates our final states. So these are initial states and these are final states. So our task to do is to minimize this DFA. First thing to do is to draw the state transition table based on this example. Here, A, B, C, D, E, and at the top you put here the input 0 and 1. So these are states A, B, C, D, E, and these are inputs for here. So based on a given DFA, here A input 0 it goes to B, and A input 1 it goes to C. So here when we input 0 in state A, it goes to B, and when we input 1 it goes to C. The same process with the state B. When we input 0 it goes to B itself, and when we input 1 it goes to D. C, when we input 0 it goes to B, when we input 1 it goes to C itself, and D, when we input 0 it goes to B, and D input 1 it goes to E, and D input 0 it goes to B, and E input 1 it goes to C. So after that, in order to minimize this DFA, step 1, we're gonna start with 0 equivalence. So how to write the 0 equivalence? You have to divide the states into two sets, one for the non-final states and one for the final states. So here are 0 equivalents. So this is our table. So this is our final states. E is our final states, and the rest is the non-final states. So here, these are non-final states. Step 2, write one equivalence. In one equivalence, take all possible pairs of states. Check if two states are in the same set. They are one equivalence, else split the states into different set. So how to check if they are in the same set? So we have table here to check if they are in the same set. Compare state A and B. A input 0 it goes to B, and B input 0 it goes to B itself. So they are in the same set. A input 1 it goes to C, and B input 1 it goes to D. Based on the 0 equivalence, they are in the same set. And next, compare A and C. A input 0 it goes to B, and C input 0 it goes to B, so they are in the same set. A input 1 it goes to C, and C input 1 it goes to C itself, they are in the same set, and so on. Next, you have to compare the A and D states. So A input 0 it goes to B, and D input 0 it goes to B. A input 1 it goes to C, and D input 1 it goes to E. Since A is in a different set, so we have to split these states to another set. So separate the D, since A and D is not equivalence, and then we'll have to copy the E since there's nothing to compare with. Next step, step 3, writing two equivalents, stop when no changes in the current set. So check if there is no changes in the current and previous set. Now you can stop the process. Since there is no changes, now we can draw our new design DFA. So These are new signed DFA. So A and C is now become one states. We have AC, B, D, E. So in a given DFA, A is our initial states. So same here, A or AC is our initial states. And E is our final states. So now this is our new design DFA. This is our initial state and this is our final state. So based on the table, AC input 0, it goes to B, and AC input 1, it goes itself, and state B input 0, it goes itself, and input 1, it goes to D, and D input 0, it goes to B, and input 1, it goes to E, and E is our final states. Input 0, it goes to B, and input 1, it goes to AC. So that's all in minimizing a DFA.